Bismillahirrahmanirrahim. This is my third video on cosmology and astrophysics. I had mentioned that we are not too much interested in theory, but to understand the subject, we have to grip theory also. The basics are also mandatory. Okay, so without wasting the time, we are interested to define a star, what the star actually is. Star actually is the self-bright bodies that made up of hot burning gases. Namely, they shine by their own light. They don't have to borrow the light by other celestial bodies. If we talk about the color of star indicates its temperature, the temperature of its surface. Okay, we have three colors: blue, yellow, and red. If the color is blue, then the temperature is maximum, and if the color is yellow, then the temperature is lesser than the above one, and if the color is red, then temperature is least, minimum temperature. Now we are quite familiar with the nuclear reaction. In star we have nuclear fusion. Nuclear fusion means to say that two hydrogen nuclei, when they combine, they form helium. Okay, now we come to key points. The first key point is, it is again definition. Star are huge celestial bodies made up of hydrogen and helium. The combination of star is hydrogen and helium elements. They produce light and heat. Okay, you may say it is a quality of a star to produce light and heat. And likewise, they are building block of galaxies. Means to say, if we write a set of billions of stars, then collectively it is a galaxy. Biggest star outside our solar system is dog star. Is dog star. Now, first of all, we have this a note or definition, you may say. In nuclear fusion of two hydrogen nuclei to form helium. Okay, this is a criteria in stars nuclear fusion. Now, uh, biggest star outside our solar system is dog star. We are interested to see the picture of dog star, so let me write here dog star. Dog star. Okay, so this is the picture of dog star. This star is outside our solar system, and it is biggest one. The next one is Proxima Centauri, is a closest star to our solar system. Closest in sense that the distance its distance is 4.2 light years away from our solar system. Just like we see, my friend is living 5 kilometers behind us, or in forward direction, so it is 4.2 light years away. Imagine, it is closest to our solar system. After Proxima Centauri, we have Alpha Centauri, that is second closest star to our solar system, and it is 4.3 light years away from our solar system. Imagine, the universe is so big. We cannot even imagine, because the celestial bodies are moving more rapidly than the speed of light. Okay, coming back, Alpha Centauri second closest, that is 4.3 light years away, and the third closest star to our solar system is Barnard star, that is 5.9 light years away. Okay, we are interested to see the picture of all these stars side by side. Okay, my dear friend, this is a picture of Alpha Centauri. We have this picture. These are two stars. This one. So, my dear friend, this is Alpha Centauri, and this is Beta Centauri, and this red circle is, if you can see, this red circle is Proxima Centauri. The last and final talk is evolution of a star. You may say different stages of a star. The very first one is protostar. Protostar means that protostar means that when the helium is huge in quantity and the outer layer of the star get expanding, then this stage is a protostar. You may say that at this stage the star is called protostar. So again, we can see the picture. This is the picture of protostar, my dear friends, and it is due to the huge quantity of helium gas. Its outer layer started expanding. After this protostar, the next stage is red giant. Although we have 6 to 7 stages of a star, that is the evolution of star, but we are only interested in first three. Only first three stages are enough. My dear friend, it is a red giant, and this is the second stage of a star. When a star becomes so much red and swelling occurs, reddening and swelling, then this stage star is called red giant. And the last and third one is, I had already mentioned that we have 6 to 7 stages, but we are only interested in first three. So, according to our lecture, the last stage is white. Okay, the last stage is white dwarf. White dwarf. This is the last stage of a star, according to our lecture. This one. Okay. My dear friend, this stage only occurs when the star has a mass just like the mass of a sun. Means to say that the mass must be comparable with the sun, or you may say uh, that the mass or sorry, the weight of white dwarf is comparable to the weight of earth. Then after the second stage, the third stage is, at third stage this star becomes white dwarf. Why white dwarf? Just because of when the reddening and swelling occurs and the helium at its climax, then after that the gases expands, and the gases expand and the star cool down and converted to the third stage, that is white dwarf. So I try my best to deliver this lecture. I hope so it is beneficial.